exercises for chapter 10, starting with the multiple choice questions. In hypothesis testing, the tentative assumption about the population parameter is the null hypothesis. The level of significance in hypothesis testing is the probability of rejecting a true null hypothesis. For a two-tailed test, an alpha equal to 0.1388, z will be equal to what? So how to find the critical value? We know that it's a two-tailed test. Since it's a z, we're going to do 0.5 minus alpha divided by 2. So 0.5 minus 0.1388 divided by 2. So this is going to be equal to 0.5 minus 0.0694. So this is going to be 0.4306. Then you go to your z table and you find where the 0.4306, which value it corresponds to. So this is your probability, and you're looking for the corresponding value. In this case, you will see that it corresponds to 1.48. For a one-tailed test, lower, that means your critical value will be negative. And alpha 0.063, the z value, the critical value will be equal to what? 0.5 minus alpha, since it's a z test. 0.5 minus 0.063, this is going to be equal to 0.437, and if you go to your z table, you will see that this corresponds to a critical value of 1.53, and since it's a lower tail, negative 1.53. So the correct answer will be B. A weatherman stated that the average temperature during July is less than 80 degrees, less than, that means less than, this is your alternative, mu less than 80, which means your null hypothesis will have mu greater or equal to 80. So the correct set of hypotheses will be A. A student believes that the average grade on the final examination in statistics is at least 85. She plans on taking a sample to test her belief. The correct set of hypotheses is at least 85. This is your null hypothesis since it contains the equal sign, greater or equal to. Therefore, the opposite will be less than. So the correct answer is C. The manager of an automobile dealership is considering a new bonus plan in order to increase sales. Currently, the mean sales rate per salesperson is 5 automobiles per month. The correct set of hypotheses for testing the effect of the bonus plan is the following. So we want to test if there is an increase in sales. So that means mu greater than 5, what it currently is. Greater than 5, this means that I'm giving you the alternative. So the correct set of hypotheses will be B, mu less than or equal to 5 for the null hypothesis. The academic planner of a university thinks that at least 35% of the entire student body attends summer school. The correct set of hypotheses to test his belief is at least, once again, is greater or equal, which means it goes under the null hypothesis. Therefore, the correct answer will be C, because the alternative will be less than 0.35. For a one-tailed test, lower tail, a sample size of 10, and alpha equal to 0.1, the t-value will be what? You will go to t-table, you will check, we have a one-tailed test, that means second row for alpha 0.1, and degrees of freedom 9. So one tail, that means second row, alpha is 0.1 right here, and then you scroll down for 0.9. So the correct answer will be 1.383. Since it's a lower tail, however, the correct will be negative 1.383. In hypothesis testing, if the null hypothesis is rejected, then the alternative hypothesis is true. The following information is given for the problems. You have n, you have x bar, sigma, and you have the hypothesis set. First off, just by the information given to you, sigma is given, so you know you're going to have a z-test. The hypothesis set is given. The alternative has mu greater than 20. That means you're going to have a one-tail, upper tail test. So the test statistic will be 24.6 minus 20 over 12 divided by square root of 36. This is going to be equal to 2.3. The critical value I have a one-tail test, it's upper, and to find the critical value, I will do 0.5 minus alpha. Alpha is 0.1, 0.4, z-table, and the critical value will give me a value of 1.28. So this point is 1.28. 2.3 for the conclusion falls inside the rejection area. It would be somewhere over here. Therefore, your conclusion will be to reject HO. Enough evidence to support mu greater than 20. For the second problem, we have the manager of a grocery store has taken a random sample of 100 customers. The average length of time it took the customers in the sample to check out was 2.9, standard deviation of 0.5. We want to determine whether or not the mean waiting time of all customers is significantly less than 3, and alpha is equal to 0.5. So, less than 3, that means I'm giving you HA, mu less than 3, HO therefore greater or equal to 3. So, that means we're going to have a one-tail left test. Test statistic, S is given, therefore I'm going to have a T test. So, that means that T will be equal to 2.9 minus 3 over 0.5 divided by square root of 100. The test statistic is negative 2. Determine the critical value. Again, as I mentioned before, we have a one-tail left, so the rejection area is to the left. Your critical value will be negative. So we check the t-table. Second row, alpha 0.05, and degrees of freedom, you have 99, but you will still check 100 because that's the closest to the 99 that you have on your table, and this will be negative 1.66. So this value here is negative 1.66. Negative 2, your test statistic, falls inside the rejection area. Therefore, the conclusion will be that we reject HO, and since we reject HO, we have enough evidence to support the fact that mu is indeed less than 3. A random sample of 16 students selected from the student body of a large university had an average age of 25 years, standard deviation of 2 years. We want to determine if the average age of all the students in the university is significantly more than 24. So alpha is 0.01. So let's start with the hypothesis set. more than 24, I'm giving you the alternative, mu greater than 24. HO will have mu less than 24. We calculate the test statistic. It's going to be a T because S is given. So we have X bar 25 minus mu 24 over S 2 divided by square root of N, which is 16. Your test statistic is 2. I have a right tail test. Since I have a t-test, I will check t-table. Second row for alpha 0.01 and degrees of freedom 15. So this will give you your test statistic, which is going to be 2.602. So this value is 2.602. The test statistic falls outside the rejection area, so your conclusion will be that we fail to reject HO. Fail to reject HO, not enough evidence to support that mu is greater than 24. For problem number 4, we have as a random sample of 16 examinations from a large population was taken. The average score in the sample was 78.6. The variance of the population, this is sigma square equal to 64. To find sigma, you have the variance. To find sigma, you take the square root of your variance, that means 8. We are interested in determining whether the average grade of the population is different than 75. So, HO will have mu equal to 75, HA different than 75. That means I have a two-tailed test, and I also have a z-test because sigma is given. So, for the z-score, for the test statistic, we will do 78.6 minus 75 over 8 divided by square root of 16. Your test statistic will be equal to 1.8. I have a two-tailed test. That means two rejection areas, one to the left and one to the right. Now, since I have a z-test, to find the critical values, I will do 0.5 minus alpha, divided by 2. So 0.5 minus 0.05 divided by 2. This will be 0.475. 0.475 will give me a corresponding value of 1.96. So the critical value will be plus minus. This will be negative 1.96. This will be positive 1.96. 1.8 falls outside. Therefore, your conclusion will be that we fail to reject HO. Fail to reject HO means that we do not have sufficient evidence to support the alternative hypothesis, which means mu different than 75. For problem number 5, we want to determine whether or not the lathe is in perfect adjustment. So that means that HO will have mu equal to 6. This is when it is in perfect adjustment. HA will have mu different than 6. So you already know that you're going to have a two-tailed test. We are using the p-value approach. So we calculate the test statistic. T is equal to X bar 6.08 minus 6 over 0.44 divided by square root of 121. Now, let's use our graphing calculator for this. Stat, test, t-test, since S is given, once again, we have mu 6, we have x bar 6.08, we have S 0.44, N 121, different than, calculate. We have our test statistic to be 2, and the p-value to be equal to 0.0478. The p-value is right here, 0.0478. So all I need to do in this case is take the p-value and compare it to alpha. Alpha is equal to 0.05. 0.05 is greater than the p-value, so we have enough evidence that mu is different than 6. Therefore, reject HO. Therefore, enough evidence that mu is different than 6. For problem number 6, a sample of 16 cookies is taken to test the claim that each cookie contains at least 9 chocolate chips. The average number of chocolate chips per cookie in the sample was 7.875 and the standard deviation of 1. So HO at least means mu greater or equal to 9, HA mu less than 9. Using the p-value approach, test if alpha is equal with an alpha equal to 0.1. So once again, I have a t-test since S is given. 7.875 minus 9 over 1 divided by square root of 16. Let's use our graphing calculator. We have stat, test, t-test. We have mu 9, x bar 7.875, S is equal to 1, N is equal to 16, less than, and calculate. So the test statistic is equal to negative 4.5, and this is your p-value. If you end up with something like this, do not be alarmed if you made a mistake. This basically tells you that you have to move this point 4 positions to the left. So that means that the p-value is really, really small. So the p-value in this case is equal to 0.000211, which is less than alpha, which is equal to 0.01. Therefore, reject HO. We reject HO. That means we have enough evidence to support the alternative hypothesis. And this concludes the exercises for chapter 10.